Applying theorems in calculus. This is another objective. All the theorems we're going to apply: intermediate value theorem, extreme value theorem, Rolle's theorem, and mean value theorem. So we're going to apply all of them. Let's figure it out, the intermediate value theorem. Intermediate value theorem is if f of x is continuous. We're going to do the conditions first, and then we go the formula, finding C. Continuous on A, B closed intervals. And there is a value of k, and there is value of k between, k means y value, okay, remember that, between f of A and f of B. Then there exists at least, this is important word, at least one value of C on AB such that f of C is equal k. So what are the conditions here? I'm going to highlight them. The conditions are if it's continuous and there is k is between f of A and f of B, and also fc is equal k. That's when it's intermediate value theorem applies. Then you do the formula. And the easy way for this, that I say that intermediate value theorem means intermediate, between. So I'm gonna say if C is between A and B and K is between f of A and f of B, then we apply the formula and it's continuous. That's another thing. Then f of C is equal k. That's the shortcut. You can write it on a memorizing page. That's intermediate value theorem. Now, how the diagram for this goes, like for example, this is A and that's a B, and we just draw a graph that goes like this. So this is technically B and this is A. So if this is A and B, then I have a C between them. If I have a C between them, then it's very, very likely that, for example, this is f of A and this is f of B. Then K has to be between f of A and f of B. It's like common sense. So this is how the formula goes for that. I mean, the diagram goes for that. Just remember, it has to be continuous on the intervals, and C is between A and B, and K is between f of A and f of B. That's another condition. And then C is, you just apply it, use the formula. That's the formula for the intermediate value theorem. Okay. Let's go back to the other one, extreme value theorem. Extreme value theorem, if you guys remember, extrema, absolute extrema has to be there when you have closed intervals, like absolute minimum and maximum, which means the greatest y value and the lowest y value. So let's see this. If f of x is, the conditions are, again, it has to be continuous. If f of x is continuous on closed interval A and B, then f has an absolute maximum and absolute minimum. Values at x equal A, or you can say x equal B, or any value of x, any value of x on AB. Like you can say any value of x, such that, now if that's the case, then what is the formula? such that f prime x is equal 0 or is undefined. So in this case, what is important? You have to look if the function is continuous on AB. If it is continuous on AB closed intervals, then we have to have a maximum, absolute maximum, and absolute minimum. Either at x equal A, either x equal B, or between them. Such that f prime is, and this is the formula that we're going to use when all these conditions are there. So you're going to make it f prime equals 0 or is undefined. And how the graph for this looks like. For example, I have a graph. It goes, this is A, that's a B, and I'm making a graph. Let's try this. I have something like that. It goes like this. So this is my B, this is my A, and I also have something here, and I can call this probably a D, and I have a C. So this is absolute maximum. This is, I'm talking about between A and B. I'm talking about between A and B. So between A and B, these are closed intervals, and this is absolute minimum. Closed interval, we have to have an absolute maximum and minimum. So this is how the graph for that looks. Now let's do the Rolle's theorem. What was the Role theorem? What are the conditions for it? The conditions are, if f of x is continuous, that's the condition. Actually the continuity condition goes for every theorem. Continuous on A and B, differentiable. Now Rolle's theorem needs differentiability too, okay? Differentiable and continuous. Differentiable on AB, and that the Role theorem is the only theorem that has 3 conditions. Like every one of them has, like, it has to be continuous. Like if you guys can check, continuous, k between f of A, f of B, this one is continuous, has to have absolute maximum and minimum. 2 conditions. Okay, I didn't highlight that. Absolute maximum and absolute minimum, that's another condition. And then over here, Role theorem is continuous, it has to be differentiable, 2 conditions. And third condition is f of A is supposed to be equal f of B. Like when you plug in this A and B in the original equation function, then the y value is supposed to be the same. Then we say, then there is at least one value of C on AB such that, what is the formula for that? F prime C is equal 0. If you guys check, that was f prime x equals 0. This is f prime C equals 0. You're going to change the x to C. Okay, so this is what I got on the Rolle's theorem. Now let's try the mean value theorem. Mean value theorem, okay, what are the conditions? I have to highlight those first. It has to be, okay, this highlighter doesn't work, so let's, okay, I have to change the color of the highlighter so we can clearly see it, probably that one. Continuous, it has to be continuous, it has to be differentiable, and f of A is supposed to be equal f of B. If these 3 conditions are there, then we apply the formula, which is f prime C equals 0. Done. Let's try the mean value theorem. Mean value theorem says if f of x is continuous on AB, indifferentiable. That's the second condition. On AB, open intervals, then there is at least one value of C on AB such that the wording for all the theorems are the same. F prime C, and this is bean value theorem, so we have to memorize the formula for this. A tangent and secant supposed to be equal, B minus A. So that's my mean value theorem. Okay, I didn't draw a graph for that one, for the Rolle's theorem. I can do it for you guys. Here is the thing. For example, my graph goes like this, and I can say this is my A, and I'm gonna say exactly the same supposed to be B, because f of A, f of B is supposed to be exactly the same. Look, so f of A, f of B the same, like y value is exactly the same. I'm gonna say this is f of A and also f of B, they are the same. Now they are horizontal tangents, horizontal tangents, horizontal tangents, so it's differentiable everywhere. And for this one, we can draw a diagram where secant and tangent slope supposed to be the same. So if I go this, I have a A, which is right there, and I have a B, which is right there. That's my secant slope right there. And when I draw a tangent on C, right here, that's a tangent on C, you can tell the tangent and the secant are parallel lines. So it means they are supposed to be equal, the tangent and secant. Okay, let's try. For this question, the rate at which water flows out of a pipe, So I usually make a diagram for this. Sometimes it helps. The rate at which water flows out of the pipe, so that's a pipe and water is flowing out of the pipe in gallons per hour, because in these kind of questions they really want the units. Is given by differentiable function R. The table below shows the rate as measured every 3 hours for a 24-hour period. So this is every 3 hours for 24, and this is RT, the water is flowing out, gallons per hour. Estimate the value of R prime 5. You know that prime 5 means it's a tangent slope they are asking me. But since I don't have an equation that I can take a derivative of and plug in 5, so I have a table. So for the table, if you have order pairs right here, like x and y's, x and y's, x and y's, then I'm going to pick arbitrarily close points, arbitrarily close to 5, and then I will do the secant slope, because you guys know that secant slope becomes a tangent anyway. So 5 is between 3 and 6. So I'm going to pick this order pair, and I'm going to pick this order pair. And I will do f of b minus f of a. R prime t equal, not t, it's supposed to be 5. R prime 5 is equal, I have R3 minus R6, and you can go the other way around, 6 minus 3, doesn't matter, over 3 minus 6, as long as you do the same order in the bottom. So I know R3 is 10.4 minus R6 is 10.8, and 3 minus 6 is -3. Plug this in the calculator, the answer is 0.133. Now this is positive, right? And also correct units of measure, explain this value means, what this value means about RT. So this is the value that's positive, so it means the rate, since R prime, that's a slope, so remember the wording, the rate of the water flows out of the pipe is increasing because we have to use the content from the question. So I'm going to say r prime 5 is greater than 0, then the rate at which water flows out of the pipe is increasing because the connection between f prime and prime, if you guys remember again, f prime x is greater than 0, then f of x is increasing. And you guys can tell this is r like an original, so I'm gonna say rx is increasing if r prime x is greater than 0. So that's the connection between these two, and that's what I explained. Is out of the pipe is increasing at t equal 5 hours. And that's what it is. Using correct units of measure, find the average rate of change. Now, average rate of change means it has to be a secant slope. You guys understand that. It has to be a secant slope from 3 to 18, like from 3 to 18. So I'm going to exactly use 3 and 18 order pair. So like 3, let's erase that one because we are done with that question. So 3 and 18, so this is 3 and that's 18. So I'm going to exactly use 3 and 18 and correct units of measure. And again, average means a secant. When you use the word average with the rate of change, it's a secant slope. They use here estimate the value of prime. Again, it's a secant slope. If you guys go back and check your memorizing page, approximate or estimate or r prime means a secant. This is also secant. If these wording was not there and I had some equation or a graph, then I will definitely do the derivative. But in this case, it's a secant. So I'm going to use R3 minus R18. You can do the other way around as long as the bottom goes the same thing. R3 is 10.4 minus 18 is 10.7 over 3 minus 18 is negative 6. When you solve this, you get 0.05 in the correct units. What are the units? It's hours and gallons. So since I have 2 hours, it's going to be squares. So gallons per hour square. Is there some time t between 0 and 24 such that, okay, remember when we were doing those what is it, the theorems, these theorems, and I said that the such that word is important here, like right here, such that, right here, such that, over here, such that, over here, such that. Every theorem has a word such that, or and at least. The word at least, and from these wording, we know that, okay, there is, this is a theorem they are talking about. So in this case, since I don't see at least, but I do see such that. So just remember which theorem has r prime t equals 0, which we have all the 4 theorems and all of them has an equations, like a formulas at the end to find a c. So which one goes here? Which theorem has this formula? And they are also talking is there sometimes t between 0 and 24, like they are not including 0 and 24, they said between 0 and 24, between 0 and 24. So I can clearly see this one is like, what is the c between 0 and 24? But what is this formula that goes with the r prime t? If you guys remember this formula, we have intermediate value theorem. I'm going to review this one more time. The formula is f of x equal k. I think it's not prime, it's f of x equal k. Yes, this one, f of c equal k. I just said f of x, but let's change this to c, make it exactly what they want, equal k. And then you have extreme value theorem where they said you have to have an absolute maximum and minimum when you have extreme value theorem, and the formula for extreme is f prime equals 0 or undefined. So this one doesn't work for the undefined. This is going to go exactly to the like it's f prime c equals 0 or undefined. Okay, extreme value theorem, they don't use that much, but intermediate value theorem, mean value theorem, and Rolle's theorem, that's very much. Rolle's theorem. Mean value theorem is f prime c is equal f of b minus f of a over b minus a. When it says mean, then I just remember average, and average is dividing something. So that's how I remember this formula. The tangent slope is equal to exactly the same as a secant. Rolle's theorem is f prime c equal 0. That's gonna what we use Rolle's theorem here. So according to Role theorem, there are conditions for the Role theorem. This is Rolle's theorem, and the conditions are it has to be continuous, differentiable, and also f of a is supposed to be equal f of b. These are the three conditions. Then we apply the formula. Now, is there some time t between 0 and 24 such that r prime is equal to? We already know it's differentiable because they said it in the beginning of the question right there. They said is given by a differentiable function r. So it is differentiable. If it's differentiable, then it's continuous, and you can tell it's continuous because every x has a y value there. It's continuous. Okay, so if it's differentiable, it has to be continuous. Now I'm gonna figure it out if f of a and f of b are the same like f of 0. So let's start with it for the first condition. Since rt is differentiable, then it is also continuous. Now I have to look for the f of b and f of a. So I can say that's a and that's b. So I'm going to see f, I'm sorry, not f. It's supposed to be r because that's what the function is. So I'm looking for r0. Let's see if r0 is equal r24. So let's go back to the table. R0 is 9.6 right there, and R24 is also 9.6. So yeah, that's good. So both of them are equal 9.6. So all the three conditions are there for the Rolle's theorem. So it means such that at least there is one t between 0 and 24 such that r prime t is equal 0. That's how we're gonna say it. Then we're going to say then Rolle's theorem guarantee a value of t on 0, 24 such that r prime t is equal 0. That's how you're going to answer it. Okay, for this question, the total order and transportation cost measured in dollars of bottles of Pepsi Cola is approximated by the function. This is the function. X is the size, order size, and number of bottles of Pepsi Cola in hundreds. Answer the following question. Is there guaranteed? When I see the word guaranteed, it means it's a theorem, one of the theorem. Value of r on the interval 0, 3 such that, again, it's a theorem. The average rate of change means a secant slope of cost is equal to c prime, which is a tangent slope at r. Give a reason for your answer. So if you guys pay attention, it says average rate of change like f of b minus f of a over b minus a is equal to c prime r. This is a mean value theorem, and the conditions for mean value theorem, it has to be continuous and differentiable. So if for the continuity, you can also do like 0 and 3 since they are included. You see these are included. Then you can plug in 0 here. You can plug in 3 here. When I plug in 0, you guys can tell it's undefined. So if it's undefined, then it means it's not continuous. So I'm going to say it's not continuous on 0 and 3. So I'm going to say, since if I would plug in the 0 and 3 or any number between them, if we didn't have those equal sign thingies like less equal or less equal, if we didn't have these things, I would plug in something in between. But since they are equal, I can plug in 0 here and then I can plug in 3 here. When I plug in 0, I can tell it's undefined. So it says if it's undefined, since C0 is undefined, when I plug in 0 in the C function, undefined, then C of x is not continuous on 0, 3, which is a closed intervals. The MVT, mean value theorem, does not guarantee a value of R on 0, 3 such that C prime R is equal C0 minus C3 over 0 minus 3. So it's undefined. You can also plug in 0 and 3 and check this out like a slope like this, because since I C prime R is going to be kind of hard. If you're using a calculator, that's good. You just take a derivative of it. If you're not using a calculator, then I'll try this side, because we know tangent and secant are exactly the same. They are equal. So either get this or that one. Part B. Is there a value of R on the interval 3 and 6, 3, 6 included, and I already write down A and B on top of it, such that that's one of the theorem, C prime equals 0. That theorem means that's a Rolle's theorem, because that's the formula for the Rolle's theorem. Give a reason for your answer. If such that R exists, then find the value of R. So according to Rolle's theorem, we have 3 conditions, and then we apply the formula. So the condition, it has to be continuous differentiable, and it has to be f of a is supposed to be equal f of b, which means f of 3 is supposed to be equal f of 6, and f prime c. After everything, we're going to do f prime c. And these kind of questions always is calculator based, because they are kind of hard to get the x value for, like to get the c and all that stuff. So the first thing, let's check the continuity. I would graph this and see if the function is continued between 3 and 6. That's one thing. If I'm not using a calculator, I'm just going to apply my continuity 3 conditions in my head. Like I'm going to plug in 3 here first and then see what I'm getting. Then I'm going to plug in 6 here and see what I'm getting. If left and right both, you know, this is left. Or less than 6, that's a limit x, R approaches 6 from the left. And this is R approaches 3 from the right. So left and right are the same, then it means it's continuous. Again, that's two ways to find continuity. The third way is, you can tell if I make the denominator equal 0, I can make this denominator equal 0, that's x equals 0. Then I have a vertical asymptote on 0. Then I can make x plus 3 equals 0, which will give me x equal negative 3. Then again at negative 3, I have a vertical asymptote. So negative 3 and x equals 0, I have vertical asymptotes. Now, 0 and negative 3 is not between 3 and 6, or not 3 or 6 either. Not between, not 3 and 6 either. So it means it's continuous on 3 or 6. So I'm going to write, since C of x is only discontinuous at x equals 0 and x equal negative 3, then Cx is continuous on 3, 6 closed intervals. 3, 6, because 3, 6 are included in there, and is differentiable, and we can take a derivative of that, and is differentiable on 3, 6. Again, for the differentiability, you can also try the limit of the derivative from the left, limit of the derivative from the right, but you have to take a derivative of this and do the limit left and right for 3 and 6, which will give me the same thing. So it is continuous, it is differentiable. What about A and B? I'm going to plug in C3 and I'm going to plug in C6. When I plugged in the 3 and 6, I'm getting the same number, 833.3333 decimal places, and you can try that. So it means Rolle's theorem guarantees a value of R such that C prime R is equal 0. Now, how do I get, since all the 3 conditions are there, how do I do this portion? I'm going to take a derivative of the C function and I'm going to make it equal 0. How do I get the X values or the R values? I am going to graph this side, I'm going to graph this side, and then we will find point of intersection. So let's go back to your calculator, and this is where I'm going to find my derivative first. So let's do the derivative. So instead of R, I'm writing X, okay, which is the same thing. Then I am going to do, let's do 10,000. That's what the formula is, 10,000. Then make a parentheses and make another parentheses. Then I have 1 over X and close the parentheses, go here, and I'm going to go plus and again X divide by parentheses X plus 3. I want to put the parentheses up for the X plus 3 because I need to show them that X is dividing by the whole thing. Then I have another parentheses over here, and then we hit enter. And you can check this if we did this right, like 1 over X plus X, and the 10,000 is multiplying with this whole thing, not just 1. So this is my actually equation for the derivative. So I'm going to go back and write down that. I'm going to say C prime is 30,000 over X plus 3 whole squared minus 10,000 over X. I think it's X squared or something. Yeah, it's X squared. So that's X squared equal 0. Now this is a derivative, that's equal 0. Now I'm going to graph this and I'm going to graph that and see the point of intersection, which will give me R. So I'm going to go back to graph and I'm going to type in all of that information there. Or we can, you guys can also highlight this. I mean, this is, I can do this because, you know, I can, I'm using a calculator on the computer. So enter. If you enter, I can only see all of this. Let me check the tab one more time if I did this right. Go back. 30,000, 10,000, X squared, yes, everything is good. So now I'm going to go back and I have to open another tab. I have to go in another tab, not that one. And I'm going to type in here 0. And then we're going to enter and fix the window, I guess. The window is going to make this negative 30,000 because that's the maximum that we have up there. And make this 30,000 positive. And see if we can see. Okay, now we can see the graph. Now this is good. Okay, that's the window. I made it since this was 30,000, the highest number, so I did that. Now I'm going to go back and find the point of intersection, analyze graph, intersection, and then you click here and you click here. The point of intersection is 4.098. So I'm going to go back. That's my R. I'm going to go back and I will say R is equal, it was 4.098, and that's my answer for the R. This part C, if you guys pay attention, it says for 3 and 9, again the 3 and 9 included, like closed intervals. What is the greatest cost? Greatest cost. What is cost? Cost means Cx, and greatest cost means, you know, Cx is a y value, right? So greatest means greatest y value for order and transportation. What theorem do you guys have there where it says greatest y value? It's extreme value theorem, which means I'm looking for absolute maximum. How do we find absolute maximum? I already told you that before too. Take a derivative, make it equal 0, get the critical points and plug them in original function, including the endpoints. Like including the endpoints and the critical point, plug them in the original. So the cx, I have to get the derivative of cx, and if you guys pay attention in part b, I already got the derivative of c function. This is the derivative of the c, and I may also made it equal 0. I also got a critical point when I graphed it, like for a point of intersection. That one was 4.098. So my critical point is 4.98, but I have to tell them this is EVT. So I'm gonna say the EVT guarantees the greatest cost for order and transportation, when x is equal 3 and x is equal 9, or x is equal 4.098, which is a critical point. So let's plug in all of them in the original. So I'm going to plug in 3 in the original, and we already did plug in 3 in the original right there. 3 and 6, we already plugged them in for 8336. So for 3, the answer is 8333.333 decimal places. Then I'm going to plug in C9. When I plug in 9, I'm getting 8611.11. You guys can use a calculator. When I plug in the critical point 4.098, I am getting 8213.670. You can plug in 0 here for 3 decimal places. So this is what I got. So which one is the greatest cost, greatest y value? This is the greatest, C9 is the greatest y value. So I'm gonna say the greatest cost is 8611.110. So that's how you do that one. For this question, a car company introduces a new car for which the number of cars sold, S, is modeled by the functions. So these S of t is the number of cars sold, where t is the time in months. Find the value of S prime 2.5. Using correct units, explain what this value represents in the context of the problem, correct units, and S prime 2.5. 3 things we have to be paying attention here. So they said find the value S prime 2.5. We did one of the question like this before, but it was saying estimate the value of S prime something, or whatever the question was. Estimate and approximate of something means you have to do the secant slope. So like in this question, I think it was the first one, this one, estimate the value of R prime 5. So they said estimate, then I have to do the secant slope. I did write tangent slope because this means a tangent slope, but when they use the word estimate, then it means I have to do the secant slope, f of b minus f of a, b minus a. Now this one doesn't say anything, so I have to, and this is a calculator based question. This is calculator, you can use a calculator on it. So I'm going to use a calculator, and I'm typing in as it is everything. Make sure you have the bottom one in parentheses, and then I'm gonna find a derivative at a point, because 2.5 is the point they are giving me. So let's go to the calculator. I'm gonna go menu, calculus, derivative at a point, and my point is 2.5. Okay, and then type in my equation, my S of t, 300. Then I have a parentheses, and it says 5 minus 9 divide, and then I'm going to make a parentheses, because if I don't do parentheses, it would give me 9 over t, like 9 is dividing by t but not plus 2. So I have to make sure that everything x plus 2 stays together. I did x instead of t. then you enter, and the answer is 133.333. So that's my S prime 2.5. S prime 2.5 is equal 133.333, 3 decimal places. That's important. Then using correct units, and then it says context of the problem, explain it. So the problem, in the context of the problem, say a new car for which the number of cars sold is S of t. So this is number of cars sold, but since we give them S prime means that's a rate, the rate at which the cars are selling. So, and that rate is positive, which means the rate is increasing. So I'm going to say, what is 2.5? I have to describe that too. 2.5 is T. T means months, right there. So I'm going to say after 2.5 months, the cars are being sold at the rate of 133 cars per month. These are the units, and done. Part B, find the average rate of change of cars sold. So what is average rate of change means? Average rate of change means that's a secant slope. Over the first 12 months, first means from starting from 0 to 12. So make sure that you guys know when it says first something months, then it's supposed to be starting 0. Indicate correct units. Again, explain what this value represents in the context of the problem. So first we have to do the average rate of change, and the average rate of change means order pairs like f of b minus f of a. So I am gonna need average. The word average goes with anything, it's gonna be a secant. Average rate of change equal, I'm gonna go, since this is S, I'm gonna start as 0 minus S12, and you can do 12 here and 0 here, doesn't matter as long as the bottom portion, the denominator, has the same order, like 0 0 minus 12 12. So when I plug this in the calculator, I got 96.429, and I plugged in 0 here in this original, I plugged in 12 in the original, I divided by negative 12, and this is what I'm getting. Okay, now context of the problem. What is this? Average rate of change is also the average rate of change, like a rate. So I'm gonna say the average. I'm gonna pick everything from the question, so it will give me a really good answer while they are talking about context of the problem, because they give you one whole full point for that. So I'm gonna say the average rate of change of cars sold over the first 12 months the average rate of change of cars sold over the first 12 months is 96. What is 96? Is 96. What are the units? My 96 of cars sold over the first 12 months is 96 cars per month. That's the unit. And done. Part C. Is it possible that a value of the value of C for 0 and 12 is included, guys, pay attention, such that it means that's a theorem, is equal to the average rate of change. Average rate of change is a secant. Give a reason for your answer, and if such a value of C exists, find the value. So what kind of theorem is this? They said S prime C is equal to the average rate of change, like S of 0 minus S12 over 0 minus 12, because that's what they said, 0 and 12. So this is mean value theorem. What are the conditions of mean value theorem? Mean value theorem means it's continuous, it has to be differentiable, and if that's the case, I have to apply this such that this. So I'm gonna figure it out if it's continuous and differentiable. Now we're going to figure it out how if it's continuous and differentiable. We already know it's differentiable because we already took a derivative using a calculator and all that stuff. The continuity, it's a rational function. Like this portion is rational, and you can tell for the rational, I always tell you guys to make the denominator equal 0, and it will give me t equal -2. That -2 is my vertical asymptote. So this is the only place this function is discontinuous. So and -2 is not between 0 and 12. So it means the function, the graph of this function is continuous on 0 and 12. It only discontinuous on -2. So that's what I'm going to say. The only value at which s of t is discontinuous is t equal -2, which is not on 0 and 12. So the mean value theorem is applicable. Okay, done. Now how do we find C? If we are looking for C, we have to use this formula. So I know I already have this part of the question because we already, I think we already figured it out, that portion which was this, 96.429. But as prime t, we have to find that. So the original function that I have is 300 parentheses 5 minus 9 over t plus 2. T plus 2. I'm going to write my function first. I have to fix this around so I don't have to use quotient rule and all of that. So I'm going to rewrite the question and then I'll take a derivative because we do need this portion. This one is already there, but this one I need, the s prime. Like s prime c, I need it. The tangent I need it, but the secant one I already have the answer for it, which is 96.429. So I'm going to rewrite this to erase that. I'm going to rewrite that. 300 times 5 is 1500 minus 2700, 9 times 300, and I got t plus 2 as it is. What can I do here to avoid my quotient rule? 1500 stays. I can do 2700 times t plus 2 in the parentheses and -1 because we know that's invisible 1 there. So if I move this to the top, it turns negative. Now I can take a derivative of this. It would be easy. S prime t, 1500 derivative is 0. Negative 2700 stays as it is. -1 jump to the front. And keep this is a quotient rule. Chain rule. T plus 2 to the power -1 is a chain rule. So outside derivative, jump to the front, keep the inside as it is, times the inside derivative, which is t derivative is 1. And this is going to go -2 because we subtract 1 all the time. Now let's fix this around. S prime t equal negative times negative is positive 2700. This t plus 2 is going to go in the bottom because it has a negative exponent. And that's what my derivative is. This is my s prime c. So I'm going to write, okay, let's write that. S prime c. I'm going to change everything to c. I have 2700 over t plus 2 whole squared. And I'm going to make this equal 90, what was that number? 96.429, which we already got from the secant slope. Now you can make a 1 here, and I told you guys when you have two fractions on both sides of equal, then make sure that you use proportion cross multiply. 2700 times 1 is 2700. 96.429 times t plus 2 whole squared. Since we need this t means that's a c actually. I said I'm going to change it, but here we go, I changed it. Then divide 96.429 both sides, 96.429. You cancel out. When I put this in the calculator, it's giving me something 27 point something 988. So I just rounded up to 28. So I got 28 here, and I still have c plus 2 whole squared. To get rid of the square, we square root both sides. So 28 square root means I have 5.292, and 2 and square root cancel out. I'm left with c plus 2. You subtract 2 both sides. I'm left with c equal 3.292. And that's the c that they wanted it. If you guys have any questions, please comment below.